Okay, let's talk about number 4 because I know that one is a little bit confusing. I saw a lot of people put 2 and 4, and you're really close with that because if lines are perpendicular, that means their slopes have to be what? Opposite signs, and then what do you do with the fraction? Flip it. So with this one, how come this one was not perpendicular to this? 1/8 and 8 are flipped, so that's right, but
the 5 and the 1 aren't.
No, it doesn't have to do with the 5 and the 1.
One's negative.
One would have to be negative, and they're not. So it can't be 2 and 4. All right, so it turns out that 1 and 3 are actually perpendicular because, and we talked about this a little bit, but I'm going to reiterate it one more time because it's really important. What is different about the equations of these two lines? Well, how do these look different than the ones we've seen so far?
They don't have the same.
Brian? They don't look right. Like they're not in slope-intercept form, right? So one of them doesn't have a slope entirely. One of them, this one has no slope, all right? This one has a slope, but it ends up being weird, and we're going to look at why. So basically what happens is when you graph these lines, so here's my coordinate plane, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, where is y equal to 5? On the y-axis, right here up at 5, okay. Isn't it also equal to 5 right here? Because this would be -1, 5. Y is 5 there, right? Isn't it also 5 here? And here? And here? So what kind of line does that actually make? Makes a straight horizontal line. So this is y equals 5. All right? And if a y equals is horizontal, what do you think an x equals is? Vertical. Good. Where would this one be? On the 2, on the x. So go to the 2, make your point, and then there it's vertical right through there. Okay? So these are special because they only have one variable. When it only has one variable, it tells you it's either a vertical or horizontal. And the y's are always, always, always horizontal. And the x's are always vertical. All right? And that's a little bit confusing because the x-axis is horizontal and the y-axis is vertical, so it's just reversed. All right, it's reversed of the way the axis is. Now, whenever those meet, they make a what? 90-degree angle. So that means that those two lines are perpendicular. Therefore, when you're looking for perpendicular lines, these ones are perpendicular because they have those. That's like that special case. All right? If this one had been negative, these would also have been perpendicular. Okay, so we did parallel and perpendicular yesterday. Does that help a little bit? Okay. All right, so we did parallel perpendicular yesterday. The last thing that we're going to talk about, so our lesson today is linear transformations. This is the last thing we're going to talk about. You guys will have a review on Monday. I think I see you twice on Tuesday, right? So we'll Kahoot on Tuesday morning, and then you'll take your test after Kahoot, okay? Me too. All right, so that means your last test of the semester is on Tuesday, so your last homework is all due on Tuesday. It's up through 5.9. If you have not done any of the homework, you have a busy weekend ahead of you, okay? So make sure you get that all done. There's 9 sections. Tuesday, it's due Tuesday. Tuesday. All right, and then we've got 3 days of review, so Thursday, Friday, and the next Monday will be all midterm review, and then you guys have your midterm on Tuesday. Did you guys see the midterm schedule? Okay, it's really confusing, especially if you look at it on your phone because it's really small. So if when we finish with the lesson, if you want to go over your midterm schedule, we can do that really quickly, okay? Because I think if I show it to you on a big screen, it's a lot easier to understand. All right? Basically, your schedule is you guys will have English on Tuesday morning, then math right afterwards. Wednesday, you go to work. Thursday, you guys just have theology. And then, so you only have one test on Thursday. And then Friday, you have biology and geography. Is that the other class you take? Geography on Friday.
Do you have to wear a uniform?
I think that usually what they do is you can wear like t-shirts, but you have to wear uniform pants. But that might be wrong. That might be wrong. So the first test is 7:30 to 9:30. The second test is 10 to 12. So if you only have 2 tests, then you're done. On Thursday, you guys will be done at 9:30.
Yeah, but like, what are they? Are you serious?
No, you can leave whenever. You can leave as soon as you're done with your test. Find out, like, the building closes at 2:30. So after 2:30, like, you can't be here. Okay. All right. So let's get started with the last little bit that we're going over today. All right. So we have been talking this whole chapter about linear functions, and a linear function is a function that makes a what? A straight line when you graph it. And that means that it has a constant rate of change, which we call slope. So every linear function is based on the same basic function. And that basic function is this blue one right here. Every single linear function, that says f of x. Remember how I said instead of f of x, you could just write y? So instead of g of x, I can write y. I'm going to change these in the whole thing, so you guys will see me do that a lot. I just change them to y's. I think it makes it a lot easier to not write it in function notation. So this is called the parent function, y equals x. All right? What do you notice about the blue line here? Why do you think it's called the parent function? It goes straight through what? The origin. It goes straight through the origin, and then what's the slope of it? 1 over 1. All right? So that's why it's the parent function, because it's essentially as basic as you can get. It goes right through the origin, and the slope is 1 over 1. And that's the basic linear function. So every linear function that we work with is some variation of this. So you basically take this blue one and either move it or tilt it or do something to it to make any other linear function. And that's what we're going to talk about today, how you transform it and what that looks like in an equation. So for example, this blue equation, y equals x, for this blue line, this is our parent function. Then you've got this red one. So consider the red one a member of its family. It's a linear function, so they're all in the same family, which means it has the same basic properties, like it has a slope, it goes through somewhere on the y-axis, it intersects with the y-axis and the x-axis, but this one's a little bit different. What's different about the red one? If you're just describing to me, what do you do from the blue one to get the red one? You move it up, right? How many do you move it up? You moved it up 3. What do you notice about the equation of the red one? It's the parent plus 3. So we have the parent function, which is y equals x. And then we said y equals x plus 3. And all that happened to your graph was you moved it up 3. Did the slope change at all? No. So that means these two lines would be what? Parallel. They're parallel lines. Yep, they don't ever touch. Those are parallel lines because they both have a slope of what? What's the slope of this if there isn't one in there? 1 over 1. What's the slope of this one? 1 over 1. All right? So those slopes are the same. All that changed was the, what's this called? Y-intercept. The y-intercept changed, but the the slope stayed exactly the same. What about with the green one? It moved down how many? 2. Look at what the equation looks like. Y equals x minus 2. Again, is the slope any different? No. All you did was move it down 2. So all that happened in the equation was that it went from the parent of y equals x to becoming y equals x minus 2. Right? So then this purple one moved down even more. How many did it move down from the parent? So then the equation would be y equals x minus 4. Right? What those are called is vertical translations. A translation just means you're sliding it. All right? And it's always going to slide vertically along the y-axis because we're changing the y-intercept. So we're only worried about vertical translations. Okay? So these are all vertical translations, which means it moves up or down. And if it moves up, that means your y-intercept is plus. If it moves down, that means your y-intercept is negative. Good. So if I have this, y equals x is my parent function, and y equals x plus 6, where would this one be compared to the parent function? On top of it, how many spots? 6. Would it be a different slope or the same slope? So those two lines would be parallel. This one, let's call it number 2, would just be on top. Okay? So that's a vertical translation. We are going to talk about 3 transformations today: translations, reflections, and rotations. All right, so that's translations. Translations just mean you move it up. So this right here, this is the key. The slope doesn't change, the y-intercept does. In a translation, the slope doesn't change, the y-intercept does. And we'll write that all down at the end too, so you have it all on the same page. All right, slope doesn't change, y-intercept does. So then I want to graph these two. I want to graph f of x equals x. We'll just call that, again, y equals x. So this is my parent function, right? So where does that start? Right at the origin, right in the middle. And then my slope goes up 1, up 1 over 1. Good. Up 1 over 1, up 1 over 1 the whole time, right? What if I wanted to go backwards? Down 1. Left 1, good. Down 1, left 1, very good. Okay, so there's my parent function. And we'll put that one in green. And then we've got this second one, which is y equals x minus 5. So describe to me, how is that going to be different? It's going to go down 5 spots. Is the slope going to change? No, so that means I start down here at negative 5, and then I go, what is my slope? Down 1. Left 1, or up 1, right 1. Good. And there it is.
Oh, so you usually just get the equation and do it, they just go, if you want to go positive, 1.
Yes. Yep. Okay, so even though mine aren't perfect, they don't look perfect because I can't draw straight lines perfectly, these two would be parallel. All right? So those are parallel. You just moved it down. So if I said to you, describe the transformation, you would say translation down 5. Or you could just say down 5. All right? However you want to abbreviate it, as long as you get the idea across that you're moving it down 5. Okay, so if you just want to put an arrow, that's fine too. Okay, so those are translations. So that just changes the y-intercept. Now, the next thing, what's happening here?
Something crazy.
It's a rotation. Why is it a rotation? Yeah, it's like spinning, right? It kind of looks, I don't know why you all groaned. I don't know, it's like, okay, it's not that scary. All right, first thing to notice, how does this one look different than the one we looked at before? They were all parallel before. These are not parallel. Instead, what do these all have in common? Giovanni? I'm sorry, I can't hear you. Hang on, guys. Go ahead. They all start right there at the origin, right? So every one of these starts at the origin. But here's my parent function. The blue one is my parent function. In my red one, what's the difference between the parent function equation and the red one? So we've got y equals 3x and y equals x. What's the difference? What goes in front of this? 1. So what am I changing here?
Oh, you're not starting at 0.
I'm starting at 0. But what changed?
3 times.
What is this thing? The slope. So what changes in the rotation? The slope. Does the y-intercept change? No, they all crossed at 0, which is why they don't have anything here, but we can put 0. See how this is in y equals mx plus b form now? 0 is the y-intercept, so you can put plus 0 if you want to. You don't have to. All right? The y-intercept doesn't change, but the slope does. All right? So they rotated. They rotated. Which way did this rotate? The blue one rotated that way. What do we call that? What are the words we used to say? Oh, it went, yes. One is clockwise, one is counterclockwise. What's clockwise mean? Goes like how a clock does, right? So clockwise is like this. All right? And then counterclockwise is the other way. So like this. Okay, so the blue one to the red one, which way did that turn? To go from blue to red. Did that go counter or did that go clockwise? Counterclockwise, because you went here and you went further up that way. All right, what about blue to green? Counterclockwise? Did that go more counter or less counter? Than the red. It went more. It went further. What do you notice about the slope of this one, which is 3, and what's the slope of this one? 5. So what do you think you can say? If you go from 3 to 5, your line rotated more. All right? So it went further counterclockwise. So you would say if I'm going from 1, which is my parent function, if that number gets bigger, I'm going counterclockwise. Right here, what happened to that number? It got smaller. So that means I'm going clockwise. If I'm going clockwise, that means the slope got smaller. If I'm going counterclockwise, that means the slope got bigger. All right, again, did the y-intercept change? No, stayed at 0. Okay, so then in this one, I'm not even going to graph these because I know right off the bat, here's my one equation, y equals x plus 2. What's the slope of that one? 1. There's nothing there, so we say 1. And then here's my second one, y equals 2x plus 2. So is that a translation or a rotation? Rotation. Did it go clockwise or counterclockwise? Counter. This went counterclockwise because the slope got bigger. So slope got bigger, so it is counterclockwise rotation. And I'm going to abbreviate that, just counter is fine. All right, counter rotation. Okay, so that's translations and rotations. So go try these 4. You don't have to graph them, just tell me what happened to them. All right, tell me what happened to go from the f of x to the g of x. Okay, so a translation changes what? A translation changes... So a translation changes what?
No,
The y-intercept. And a rotation changes the slope. This one, this is the last one, is a reflection. And a reflection is just a flip. So it just flips over, okay? So from the blue one to the red one, it just flipped. What changed from this equation to this equation? Positive became a negative. Which? The y-intercept or the slope? Slope. The slope. There is no y-intercept because both of these start where? At 0. So there is no y-intercept there. They both start at 0. So this is 2x plus 0, and this is 2x plus 0. The only thing that changed is the red one was negative 2x, and the blue one was positive. So if it reflects, that means the slope sign is opposite. All right, the sign is opposite. The number doesn't change, but the sign is opposite. Okay, so for these, I want to figure out if there's multiple things happening. I want to figure out what changed. So again, the blue one is our parent, and then we've got the green one. So just look at the green one right now. What happened from the parent of f of x equals x to get h of x? And again, both of these can just be written as y. What changed here? Is this a rotation, a reflection, a translation, or multiple? It's a rotation. Why is it a rotation? The only thing that changed was the slope, and they're both still positive, so you know it's not a reflection. All right? And so the slope changed. Is the slope getting bigger or smaller? Bigger. So that means it rotated. Which way is that? Counterclockwise. So this would be a counterclockwise rotation. All right? So that would be a counterclockwise rotation. What about from f of x equals x to g of x equals 3x plus 1. What changed here? The slope and the y-intercept, which means this was still a rotation because it's got the same slope here. So that was a rotation, but what else did it do? It went up 1. Exactly. So that's what we call multiple translations or transformations. So you rotate counterclockwise and translate up. All right? So if I gave you a question on a quiz, this is the kind of answer you would need to put. Like rotate it counterclockwise, translate it up or down. Okay? And so I'm going to do on a blank slide, you guys might have room to copy this on a different slide. All right, so these are our transformations. And this is like what happens. So our first transformation is a translation. All right, what changes in a translation?
The intercept.
Y-intercept changes. That's it. Just the y-intercept changes. All right, what happens in a rotation? Yeah, the changes like positive, negative, or the number actually changes? Number actually changes. So the slope increases if it's counterclockwise, or slope decreases if it's clockwise. And then last but not least, reflection. What happened to the slope? Slope goes from negative to positive or vice versa. So slope sign plus or minus changes. And those are the 3 linear transformations that you would need. So those are the 3 ones that you would need. So then for this one right here, and I'm going to leave this up at the top, all right, from this one right here, y equals x to y equals 1/2 x minus 6, what changed? What changed? The slope and the intercept. So that means, was it a rotation, a reflection, a translation, or multiple? Multiple. What was it? It translated which way? Up or down? Down. So it went down 6, translate down 6. And then it rotated clockwise. All right, and it rotated clockwise because the slope got smaller. Okay, so at your boards, I want you to tell me, no, that's it. I think that's it. I want you guys just to do the exit ticket. All right, so go ahead and do the exit ticket. You do not need to graph any of them if you don't want to. You can if you need help figuring out what happened, or you can just describe to me in words like we just did what the changes were, okay? So for the numbers 1 and 2, you're describing the changes. For number 3, you're writing a new equation based on what it tells you. Okay, just do them right on the slides when you're done. Show them to me.